Imagine hearing a bird sing outside your window and realizing you are listening to the last living dinosaurs on Earth. For over 160 million years, dinosaurs ruled this planet. They walked through glowing forests, shook the ground with every step, and shaped life as we know it. But one moment in space changed everything. Tonight, we will travel back through deep time to giant creatures, fossilized memories, and the catastrophic event that ended their world. And as you relax, you'll discover how dinosaurs never truly disappeared. They transformed, and they are still with us today. Close your eyes, breathe slowly, and let this journey into the age of giants begin. Hello there, and welcome back to Dreamy Science Stories. Tonight, we'll drift gently through deep time to an era that feels almost like a dream. Close your eyes for a moment and imagine a world before cities, before humans, before even the sound of birdsong as we know it. A world where endless forests stretched across ancient continents, where giant ferns brushed the sky, and the ground trembled beneath footsteps heavier than anything alive today. This is the lost world of the dinosaurs. They were not just monsters with teeth and claws from old movies. They were delicate, feathered, swift, slow, tiny, colossal, and astonishingly diverse. Some were no bigger than a house cat, hiding among leaves and insects. Others were living mountains, their shadows stretching across valleys. For more than 160 million years, dinosaurs shaped the Earth. They lived through shifting continents, rising oceans, and changing skies. And although they are gone, they are not truly lost. Their bones still lie beneath deserts and oceans. Their feathers are trapped in amber, glowing softly like time frozen in honey. Their footprints remain pressed into stone, silent whispers of a vanished age. And every bird you see today, every sparrow, eagle, and owl, is a living dinosaur carrying ancient history in its wings. If you enjoy these gentle journeys through science and deep time, you can like and subscribe, or share a quiet thought in the comments below. It helps other sleepy explorers find their way here, too, one calm mind at a time. But for now, get comfortable. Let your thoughts slow, and together, let's wander into the ancient world of the dinosaurs. Sauropod dinosaurs were never really lizards. The word dinosaur comes from Greek, meaning terrible lizard. But in truth, dinosaurs were never really lizards at all. When scientists first discovered their bones in the 1800s, they imagined giant versions of modern reptiles. Huge lizards stomping through prehistoric jungles. It was a reasonable guess, but a very incomplete one. As more fossils were uncovered, scientists began to realize something astonishing. Dinosaurs stood upright, with their legs directly beneath their bodies like birds and mammals, not sprawled to the sides like modern lizards. Their hips, bones, lungs, and even their growth patterns were unique. In fact, dinosaurs are closer relatives to birds than to lizards. Birds are not distant cousins. They are living dinosaurs, the last surviving branch of an ancient family tree. So while the name terrible lizard remained, the reality was far more magical. Dinosaurs were not simply reptiles. They were a completely unique experiment in life's history, one that lasted longer than almost any other. Globe-showing Europe-Africa dinosaurs ruled Earth for over 160 million years. It's difficult for the human mind to understand deep time. Our entire recorded history fits into a tiny fraction of a single geological second. Humans have existed for a few 100,000 years. Dinosaurs ruled the planet for more than 160 million years. During their reign, continents drifted apart like slow-moving ships. Mountain ranges rose. Deserts formed where oceans once flowed. Forests turned to stone, and new ecosystems replaced old ones. Dinosaurs adapted to all of it. They lived in steamy jungles, icy polar regions, coastal plains, deserts, and highlands. They survived ice ages, heat waves, volcanic eruptions, and changing atmospheres. They were not failures or evolutionary mistakes. They were among the most successful animals ever to exist. Compared to dinosaurs, humanity is just beginning its journey. Hatching chicks, some dinosaurs were smaller than chickens. When most people think of dinosaurs, they imagine giants. Towering tyrants with teeth like daggers. Long-necked giants that could reach treetops. But many dinosaurs were tiny. Some were smaller than modern chickens. Species like Microraptor were only about 2 feet long, light enough to climb trees and glide between branches. Their bodies were covered in feathers that shimmered with iridescent colors, like beetle wings catching sunlight. These little dinosaurs were quick, clever hunters, chasing insects and small prey through dense forests. They were not lumbering giants. They were delicate, bird-like jewels of the ancient world. Dinosaurs filled every ecological niche imaginable, from giants that ate forests to tiny creatures that lived among leaves. Evolution painted with a vast palette, creating forms both massive and miniature. Airplane, the largest dinosaurs, weighed more than a Boeing 747. Now imagine the opposite extreme. Picture standing beside an animal heavier than a modern airplane. That was the reality of the largest sauropods, dinosaurs like Argentinosaurus and Patagodoton. Scientists estimate some weighed over 70 tons, rivaling a fully loaded Boeing 747. Their necks stretched longer than buses. Their hearts had to pump blood incredible distances upward. Their lungs used bird-like air sacs to keep oxygen flowing through their gigantic bodies. When these giants walked, the ground likely trembled. Forests bent beneath their feeding. Rivers shifted as herds passed through. They were the largest land animals to ever walk the earth. Not machines, not myths, living, breathing creatures shaped by evolution. Person-running, some dinosaurs could run faster than Olympic sprinters. Not all dinosaurs were slow giants. Some were built for speed. Lightweight theropods like Ornithomimus had long legs, slim bodies, and stiff tails that acted like balancing rods. Scientists believe some could run over 40 miles per hour, faster than Olympic athletes. Imagine them sprinting across ancient plains like prehistoric ostriches, dust rising behind them. Speed was their shield, their escape from predators. In a world of giants, sometimes survival meant being fast, not big. The tiniest dinosaur eggs were smaller than quail eggs. Dinosaurs began life in fragile shells. Some of the smallest fossil eggs ever found are no larger than marbles, smaller than modern quail eggs. Picture a hidden nest in soft soil, lined with leaves. Tiny speckled eggs resting quietly, waiting for warmth and time. Inside each egg, a tiny dinosaur embryo curled, fragile and vulnerable. Many nests have been fossilized with embryos still inside, frozen in time like a prehistoric lullaby. Even the mightiest creatures began as something delicate and uncertain. Basketball, the largest dinosaur eggs were bigger than basketballs. At the other end of the scale, some dinosaur eggs were enormous. Sauropod eggs could be larger than a basketball. Imagine walking across an ancient desert and finding a nest of giant eggs buried in sand, each one holding a future titan. Sauropods likely laid dozens of eggs at once, knowing that only a few hatchlings would survive predators. Fossil nesting grounds reveal vast colonies where dinosaurs returned year after year, creating prehistoric nurseries. Life, even at colossal scale, began with fragile shells. Many dinosaurs had feathers, not scales. For decades, dinosaurs were imagined as scaly reptiles. But modern fossils have changed everything. Many dinosaurs, especially smaller ones, were covered in feathers. Some had fluffy down, others had complex plumes for display, warmth, or gliding. Imagine a velociraptor with sleek feathers, darting through ferns like a giant predatory bird. Some fossils preserve feather impressions so clearly that they appear like soft halos around the bones. Feathers did not start with birds. Birds inherited them from dinosaurs. And when you watch a bird today, you are watching a tiny living echo of the dinosaur age. We'll take another gentle step into the deep past, drifting across oceans of time to a world that feels almost like a dream. A world where the land was greener, the air heavier, and enormous creatures moved across the earth with slow, thunderous steps. Close your eyes for a moment and imagine it. Endless forests stretching to the horizon. Strange calls echoing through the trees. Shadows moving in the mist. This was the age of dinosaurs, a world that existed for so long that human history is only a brief whisper compared to it. Dinosaurs were not just giant monsters. They were families, communities, entire ecosystems. Some were small and delicate, others impossibly massive. Some soared through the air, some walked quietly beneath the ferns, and some ruled the land as apex predators. Even though they vanished millions of years ago, their presence still surrounds us. In fossilized bones, in footprints preserved in ancient stone, in feathers trapped in amber. And perhaps most beautifully of all, in every bird that sings outside your window today. So, if you enjoy these calm journeys into science and deep time, you can like, subscribe, or share a quiet thought in the comments. It helps others find their way here too, one sleepy traveler at a time. Now get comfortable, breathe slowly, and let's drift into the lost world of the dinosaurs. Herb dinosaurs were never really lizards. The word dinosaur comes from Greek, meaning terrible lizard. But in reality, dinosaurs were never truly lizards at all. When scientists first discovered dinosaur bones in the 1800s, they imagined giant versions of modern reptiles. Their understanding was limited, and the name stuck. But over time, fossils revealed a much stranger and more fascinating truth. Dinosaurs walked with their legs directly beneath their bodies, giving them an upright posture more like birds and mammals than lizards. Their bones grew quickly, their lungs were efficient, and their hips and skeletons were uniquely structured. In fact, dinosaurs are far more closely related to birds than to reptiles like lizards or snakes. So every time you see a pigeon, a sparrow, or an eagle, you are looking at a living dinosaur descendant, tiny echoes of a once dominant lineage. Hourglass-not-done dinosaurs ruled the earth for an unimaginable time. Dinosaurs ruled the planet for more than 160 million years. To put that into perspective, modern humans have existed for only a few 100,000 years. Recorded history is just a blink in time. While dinosaurs walked the earth, continents drifted apart, oceans opened and closed, climates changed from steamy jungles to frozen polar regions. Entire ecosystems rose and disappeared. Dinosaurs adapted to all of it. They survived ice ages, volcanic eruptions, shifting continents, and changing atmospheres. They were not failures of evolution. They were one of the most successful groups of animals ever to live. Humanity, by comparison, is a very recent visitor to this ancient party. Hatching chicks, some dinosaurs were smaller than chickens. When we think of dinosaurs, we imagine towering giants. But many dinosaurs were tiny. Some were smaller than a chicken, light enough to leap through branches or glide through the forest canopy. Creatures like Microraptor had feathers and wings on both their arms and legs, making them look like four-winged birds. They may have glided between trees, hunting insects and small animals. Their feathers could shimmer in the sunlight, reflecting blues and greens like beetle shells. These tiny dinosaurs remind us that evolution doesn't always favor size. Sometimes being small, quick, and clever is the best survival strategy. Small airplane, the largest dinosaurs weighed more than a Boeing 747. At the opposite extreme were the giants. Some sauropods, like Argentinosaurus and Patagodoton, weighed over 70 tons, more than a fully loaded Boeing 747 airplane. Their necks stretched like bridges, their tails swept the ground like giant whips, and their footsteps would have made the earth tremble. Their hearts pumped blood up necks longer than buses, and their lungs were filled with bird-like air sacs to keep their bodies light. They were living skyscrapers, walking slowly through prehistoric plains. No land animal before or since has ever reached such colossal size. Person-running some dinosaurs were faster than Olympic sprinters. Not all dinosaurs were slow giants. Some were built for speed. Lightweight dinosaurs like Ornithomimus looked like giant ostriches and may have run faster than 60 kilometers per hour. Imagine herds of sleek dinosaurs sprinting across ancient plains, dust rising behind them, tails held straight like balancing poles. Speed was their shield against predators, just as gazelles rely on speed today. The smallest dinosaur eggs were tiny and fragile. Some dinosaur eggs were no larger than a marble. These delicate eggs belonged to tiny feathered dinosaurs, and inside each one was a fragile embryo curled like a sleeping bird. Fossil nests have been found preserved in stone, capturing moments frozen in time. Tiny eggs, tiny lives, enormous uncertainty. Even the most powerful creatures on Earth began life as something soft, small, and vulnerable. Basketball, the largest dinosaur eggs were bigger than basketballs. Meanwhile, the giants laid enormous eggs. Some sauropod eggs were larger than a basketball. Entire nesting grounds have been discovered with hundreds of eggs laid together. These dinosaurs relied on numbers. Most hatchlings would not survive, but a few would grow into titans longer than buses and heavier than planes. Many dinosaurs had feathers. For decades, dinosaurs were imagined as scaly monsters. But fossils tell a different story. Many dinosaurs were covered in feathers, sometimes fluffy, sometimes elaborate, sometimes wing-like. Velociraptors likely looked more like fierce birds than reptiles. Feathers kept them warm, helped with display, and may have allowed gliding or early flight. Rainbow-some dinosaurs were colorful and shimmering. Microscopic structures in fossil feathers reveal colors. Some dinosaurs were black, red, or even iridescent, shimmering like hummingbirds. The prehistoric world was not gray and dull. It was vibrant, colorful, alive with motion and light. T-Rex had the most powerful bite ever on land. Tyrannosaurus rex could bite with a force of up to 12,000 pounds. Its teeth were thick, banana-shaped, and serrated for crushing bone. When T-Rex bit, bone shattered. Armor failed. Prey had no escape. Yet it may have been both a hunter and scavenger, intelligent, strategic, and terrifying. Brain Stegosaurus had a tiny brain. Stegosaurus had a brain the size of a walnut. Despite its massive body and armored plates, its brain was small. But intelligence isn't everything. Stegosaurus survived through armor, spikes, and adaptation. Evolution values survival, not IQ. Bus sauropods were longer than 3 school buses. Some sauropods stretched over 100 feet long. Their necks reached treetops. Their tails balanced their massive bodies. Their bones were hollow to reduce weight, like modern birds. Standing beside one would feel like standing next to a moving building. Beaming face with smiling eyes, some dinosaurs had over 1,000 teeth. Hadrosaurs had hundreds of teeth arranged in batteries, constantly replacing worn ones. They were nature's plant processing machines, grinding tough vegetation efficiently. Rhinoceros triceratops had giant horns. Triceratops' horns could grow over 3 feet long. They fought predators, rivals, and displayed dominance. Fossils show healed wounds from combat. Shield ankylosaurs were living tanks. Ankylosaurs had armor so strong that even T-Rex struggled to bite through it. They also had tail clubs that could break bones with a single swing. Hammer dinosaur tail weapons. Some had massive bone clubs. Others, like Stegosaurus, had sharp spikes called a thagomizer. One swing could impale a predator. Hedgehog Stegosaurus and its deadly spiked tail. Predators foolish enough to come too close risked a painful and often fatal encounter. At the end of the Stegosaurus tail were long, dagger-like spikes, capable of piercing flesh and bone. These spikes were not ornamental. They were weapons, shaped by millions of years of evolution in a constant arms race between hunter and prey. Imagine a massive Stegosaurus slowly walking through a prehistoric forest. Its back plates rising like sails in the mist, its heavy tail swaying behind it. A predator approaches, thinking it has found an easy meal. But in a flash, the Stegosaurus swings its tail in a wide arc. The spikes cut through the air and strike with bone-cracking force. Combined with its thick skin, bony plates, and enormous size, this tail made Stegosaurus far more dangerous than its small brain might suggest. Intelligence was not its main defense. Armor and instinct were. Stegosaurus reminds us that dinosaurs evolved a stunning variety of defensive strategies. Some relied on speed, some on camouflage, and others on living armor and natural weapons. Evolution did not choose one path. It experimented with many. Toothed dinosaurs could replace their teeth for life. Unlike humans, who grow only 2 sets of teeth, many dinosaurs had a built-in system for constant renewal. Their teeth were not permanent tools. They were disposable, endlessly replaceable weapons and grinders. Predators like Tyrannosaurus rex wore down their teeth by crushing bone, tearing flesh, and fighting rivals. But as soon as a tooth cracked or wore out, another was already forming beneath it, ready to rise into place. Some dinosaurs replaced teeth every few weeks. Herbivores needed this just as much as carnivores. Grinding tough plants quickly wore teeth down, so constant replacement was essential for survival. Fossilized jaws sometimes reveal rows of developing teeth stacked like conveyor belts, each one waiting its turn. It is a surreal image, jaws that never truly went dull. This feature still exists in crocodiles today, linking them to their distant dinosaur relatives. For dinosaurs, teeth were renewable tools as vital as claws, horns, or armor. Turkey Velociraptor was only the size of a turkey. Hollywood turned Velociraptor into a towering monster. But reality tells a different, more fascinating story. True velociraptors were about the size of a turkey, weighing around 15 to 20 pounds. They were feathered, agile, and bird-like, more like predatory hawks than giant reptiles. Yet their small size did not make them harmless. Velociraptors were equipped with razor-sharp teeth and a large sickle-shaped claw on each foot. This claw could slash deeply into prey with precision and speed. One famous fossil shows a velociraptor locked in combat with a protoceratops, both animals frozen mid-battle for eternity. It is a snapshot of prehistoric violence captured in stone. Velociraptors relied on agility, intelligence, and precision rather than brute force. In their ecosystems, they were efficient hunters and opportunistic scavengers. Their story teaches us that danger is not always measured in size. Sometimes the smallest predators are the most precise. Wolf-faced raptors may have hunted in packs. One of the most intriguing possibilities is that raptors hunted cooperatively. Some fossil sites contain multiple raptor-like dinosaurs together, suggesting they may have lived or hunted in groups. Imagine a pack of feathered hunters spreading out through a clearing. Some drive prey forward, others circle quietly from the sides. When the moment is right, they strike in coordinated bursts of movement. Whether Velociraptor itself hunted this way is debated, but related species show strong evidence of social behavior. If true, these dinosaurs were not just physically dangerous. They were strategic, coordinated, and intelligent. Teamwork is one of nature's most powerful weapons, and it may have evolved long before humans ever walked the earth. Bone dinosaurs had hollow bones like birds. When scientists first examined dinosaur bones, they discovered something surprising. Many bones were not solid. They were hollow, filled with air spaces, and supported by thin internal structures. This design made bones strong yet lightweight, an engineering marvel millions of years ahead of human technology. Hollow bones allowed enormous sauropods to support their massive bodies and helped smaller theropods run swiftly, or even take to the air. Birds share this adaptation today. Their hollow bones help them fly and stay light. This is another powerful link between dinosaurs and modern birds, showing how ancient traits persist through time. Dinosaur skeletons were not crude structures. They were masterpieces of biological architecture. Birds are living dinosaurs. Perhaps the most astonishing fact is this: dinosaurs never truly disappeared. Every bird alive today is a direct descendant of theropod dinosaurs. Feathers, hollow bones, nesting behavior, wishbones. These traits all trace back to dinosaur ancestors. When you see a pigeon on a city street or a hawk soaring above a field, you are looking at a modern dinosaur. Dinosaurs did not vanish. They transformed. They adapted. They took flight. The world around us is filled with living fragments of deep time, still singing, still flying, still evolving. Dove Archaeopteryx, a bridge between dinosaurs and birds. In the 19th century, a remarkable fossil was discovered in Germany, Archaeopteryx. It had teeth, claws, and a long bony tail like a dinosaur, but also feathers and wings like a bird. Archaeopteryx was a transitional creature, a snapshot of evolution in motion. It likely glided between trees, flapping in short bursts, experimenting with the early stages of flight. Its fossil feathers show intricate detail, revealing both function and beauty. For decades, Archaeopteryx was a symbol of evolution, showing how one group of animals could gradually transform into another. Looking at it feels like peering into evolution's workshop, where flight itself was being invented. Fire dinosaurs were likely warm-blooded. For many years, dinosaurs were depicted as slow, cold-blooded reptiles, but evidence suggests many were warm-blooded, more like birds and mammals. Bone growth patterns, chemical analysis, and feather discoveries indicate that dinosaurs maintained stable internal body temperatures. This would have allowed them to be active hunters, long-distance travelers, and attentive parents. Imagine herds of warm-blooded dinosaurs migrating across continents, their bodies generating heat as they crossed changing climates. The prehistoric world was not a land of sluggish giants. It was vibrant, energetic, and alive with movement. Wind-faced dinosaurs had advanced air sac systems. Breathing at the scale of a giant sauropod required extraordinary adaptations. Many dinosaurs evolved complex systems of air sacs connected to their lungs, similar to modern birds. These air sacs allowed oxygen to flow in one direction, providing a constant stream of fresh air. This system was far more efficient than human breathing and helped fuel enormous size and high activity levels. Fossilized bones with internal chambers reveal where these air sacs once existed. It is a hidden respiratory network preserved in stone. Dinosaurs were not just big, they were optimized for life at every scale. Tornado Diplodocus and the sonic tail whip. The tail of Diplodocus was long, flexible, and powerful. Some scientists believe it could be snapped like a whip at incredible speeds, possibly even breaking the sound barrier. If true, the crack of a Diplodocus tail would have been one of the loudest sounds produced by any land animal. A prehistoric sonic boom echoing across ancient plains. This tail could have been used for defense, communication, or display. Imagine herds of Diplodocus swinging their tails in rhythmic motions, signaling to each other across vast landscapes. Whether every detail is proven or not, the anatomy of Diplodocus shows how evolution experimented with extraordinary possibilities. Crescent moon dreamy sleepy transition. And as the prehistoric world slowly fades into the distance, we are left with echoes. Feathers in amber, bones in stone, birds in the sky. Dinosaurs are not just fossils in museums. They are part of the living world around us, part of the deep story of life on Earth. So let your mind wander among ancient forests, feathered hunters, and giants snapping their tails beneath alien skies. Drift gently into sleep, knowing that the world you live in is shaped by creatures that walked this earth long before us. Waterwave the many uses of a dinosaur tail. A dinosaur's tail was far more than a simple extension of the body. It could serve as a counterweight, a defensive weapon, and perhaps even a tool for communication. Some tails may have cracked like whips, others swung like hammers, and others helped stabilize massive bodies as they walked, ran, or swam. Imagine the prehistoric plains at dusk, a herd of long-necked giants slowly moving forward, their tails swaying rhythmically to balance their enormous bodies. Nearby, a predator flicks its tail as it turns, maintaining perfect balance while stalking prey. And in the distance, a sharp crack echoes across the land, perhaps a tail snapping through the air like thunder. The tail was not an afterthought in dinosaur evolution. It was a multi-purpose instrument, shaped by millions of years of experimentation, turning bone and muscle into one of nature's most versatile tools. Crocodile Spinosaurus, the river hunter. Among all dinosaurs, Spinosaurus stands out as one of the strangest and most mysterious. With its long, narrow snout filled with cone-shaped teeth, it resembled a gigantic crocodile more than a typical land predator. Its tall sail-like structure on its back added to its otherworldly silhouette, rising like a living banner above its spine. But what truly set Spinosaurus apart is how it may have lived. Fossils suggest that it was partially adapted to an aquatic lifestyle. Its bones were unusually dense, helping it stay submerged rather than float. Its tail, flattened and powerful, may have acted like a paddle, propelling it through rivers and lakes. Imagine this colossal predator sliding silently beneath murky waters. Fish scatter. Smaller dinosaurs approach the shoreline unaware. In a sudden burst of movement, the Spinosaurus lunges, jaws snapping shut around its prey. This creature challenges our assumptions about dinosaurs. It was not confined to land. It explored a semi-aquatic existence, becoming a master of both riverbanks and watery depths. Spinosaurus reminds us that evolution often blurs boundaries, creating creatures that defy simple categories. Waterwave dinosaurs that could swim. For a long time, dinosaurs were imagined as creatures tied strictly to land. But the fossil record tells a different story. Trackways preserved in ancient riverbeds showed dinosaurs wading, paddling, and even swimming across bodies of water. Their footprints appear, then vanish, suggesting a transition from walking to floating. Large theropods may have crossed wide rivers, their buoyant bodies supported by air-filled bones and lungs. Smaller dinosaurs likely swam with ease, darting through ponds or lakes in search of fish or aquatic plants. Some may have used water as a refuge from predators. Picture a prehistoric river shimmering in sunlight. A herd of herbivores approaches the bank, cautiously stepping into the water. A predator follows, but hesitates, knowing the water changes the rules of the hunt. Swimming expanded the dinosaur world, allowing them to access new food sources, escape danger, and travel across landscapes shaped by rivers and floods. Dinosaurs were not just land giants. They were versatile explorers of Earth's many environments, evergreen tree gliders of the ancient forest. Long before birds mastered powered flight, some dinosaurs experimented with gliding. Small feathered species may have launched themselves from tree branches, spreading feathered limbs or membrane-like wings to drift through the air. Imagine a dense prehistoric forest canopy. Tiny dinosaurs scurry up tree trunks, leap into the air, and glide silently from branch to branch. Their feathers shimmer softly in filtered sunlight as they descend, landing lightly on distant trees. These early gliders represent evolutionary experiments, nature testing the possibilities of air. Not true flight, but a step toward it, a living blueprint for wings, written millions of years before birds took full control of the skies. Eagle pterosaurs, masters of the sky. While dinosaurs ruled the land, pterosaurs dominated the skies. Though often confused with dinosaurs, they belonged to a separate branch of reptiles. They were the first vertebrates to achieve true powered flight. Some were small, fluttering like birds. Others were giants with wingspans over 30 feet, soaring like living gliders over oceans and coastlines. Some skimmed fish from the water's surface. Others walked on land with long-beaked jaws, hunting prey with precision. Imagine the Mesozoic sky filled with winged silhouettes. Massive pterosaurs circling above, smaller ones darting through the air, all sharing the world with dinosaurs below. The prehistoric sky was not empty. It was alive with motion, shadows, and ancient wings beating against warm air currents. Egg nests of life, dozens of eggs at a time. Dinosaurs developed extraordinary reproductive strategies. Some species laid dozens of eggs in a single nest, creating vast nurseries across ancient landscapes. Sauropods, in particular, may have relied on sheer numbers, knowing that only a few hatchlings would survive predators and harsh conditions. Fossilized nesting grounds show hundreds of eggs clustered together, suggesting that herds returned to the same locations year after year. These sites must have been filled with life and danger, newborns emerging, predators lurking, and adults guarding or simply moving on. Imagine a wide sandy plain dotted with nests. Tiny hatchlings breaking free from shells, their world already full of peril. Life began fragile, even for creatures destined to become giants. Hatching chick dinosaur parents and their young. Some dinosaurs did not abandon their offspring. Fossil evidence suggests that certain species kept their young in nests for weeks or months. These hatchlings were too weak to survive alone, relying on parental care and protection. Picture a nest filled with downy babies chirping softly. A parent stands nearby, shielding them from sun or predators. Perhaps food is brought to the nest, or the young are guided to safe feeding grounds. This behavior feels deeply familiar. It mirrors birds today, reinforcing the evolutionary bridge between dinosaurs and modern avian life. Dinosaurs were not just cold, distant reptiles. Some may have formed family groups, nurturing their young with care and cooperation. Pawprints herds on the move. Sometimes the most powerful fossils are footprints. Vast trackways show dinosaurs walking together in large groups, suggesting social behavior and herding. Imagine hundreds of dinosaurs moving across open plains. Adults on the outside, young protected in the center. Their footsteps synchronized, their movements slow and steady. Dust rising under massive feet, stretching toward the horizon. These trackways capture moments frozen in time: migration, daily travel, or escape from predators. They reveal dinosaurs as social creatures, living in structured communities rather than wandering alone. Globe showing Europe-Africa ancient migrations across continents. Dinosaurs may have traveled astonishing distances. Some species likely migrated hundreds of miles in search of food, water, and favorable climates. Chemical signatures in fossil teeth and footprints suggest seasonal journeys across vast landscapes. Imagine endless lines of dinosaurs crossing floodplains and forests, guided by instinct. Predators shadowing herds. Pterosaurs gliding overhead. Seasons changing as they move, chasing abundance across shifting continents. Migration connected distant regions and shaped ecosystems. It shows that dinosaurs were not static inhabitants of a single place, but dynamic travelers across the ancient world. Snowflake dinosaurs on every continent. Dinosaurs were global pioneers. Their fossils have been discovered on every continent, including Antarctica. Today, Antarctica is frozen and barren, but millions of years ago it supported forests, rivers, and dinosaurs roaming through temperate landscapes. As continents drifted apart, dinosaurs adapted to new environments: deserts, forests, coastlines, and polar regions. Their global spread explains their incredible diversity, with unique species evolving in isolated regions. From equator to poles, dinosaurs left their mark. Footprints, bones, nests, and feathers scattered across the planet, telling a story of worldwide domination and adaptation. Globe showing Europe-Africa, a planetary dynasty. Dinosaurs were not just successful animals. They were a planetary dynasty, ruling more of Earth's land for longer than any other group of large terrestrial creatures. Their reign stretched across continents, climates, and geological eras. They walked on lands that no longer exist, across continents that have since drifted apart. They lived through volcanic eruptions, shifting oceans, and changing skies. Their story is written into the very shape of the continents we see today. For millions of years, the Earth itself was a dinosaur world. Evergreen tree Antarctica, the lost green continent. Today, Antarctica feels like another planet. Endless ice, howling winds, and a silence broken only by cracking glaciers. But in the age of dinosaurs, Antarctica was something entirely different. It was once a green continent, covered in forests, rivers, and rich ecosystems. Fossilized trees, leaves, and dinosaur bones reveal a warm and fertile land where life flourished. Sauropods wandered among towering conifers. Theropods hunted in dense woodlands. Ornithopods grazed in lush clearings. Imagine standing in an ancient Antarctic forest. Sunlight filtering through tall trees. Ferns carpeting the ground. Dinosaurs moving slowly between trunks, their footsteps soft on moss and soil. The seasons were extreme. Long summers bathed the land in endless sunlight. Winters plunged it into months of darkness. Dinosaurs here had to adapt, perhaps growing thick coats of feathers, storing energy, and developing behaviors to endure prolonged night. These polar dinosaurs remind us how dramatically Earth's climate has changed. Antarctica was once alive with green life, a forested world at the edge of the planet, preserved forever in stone. Snowflake dinosaurs beyond the Arctic Circle. Antarctica was not the only polar home. Dinosaurs also lived near the North Pole. Fossils found in Alaska and other Arctic regions reveal that dinosaurs roamed far above the Arctic Circle. These animals endured long winters, limited sunlight, and harsh conditions. Trackways suggest that some herds lived there year-round rather than migrating south. They adapted to cold climates in ways we are still discovering. Imagine a prehistoric Arctic landscape. Snow-covered forests. Herds of dinosaurs moving through pale winter light. Warm breath rising in clouds from their nostrils. Predators stalking in the half-darkness, their silhouettes stretching across frozen ground. These Arctic dinosaurs show that dinosaurs were not just tropical creatures. They were among the most adaptable animals to ever live, thriving at the very edges of habitable Earth. New moon surviving months of darkness. In polar regions, winter meant months without sunlight, yet dinosaurs endured. Fossil evidence suggests some had large eyes suited for low light, while others relied on social behaviors for warmth and protection. Their warm-blooded metabolisms would have helped them stay active when cold-blooded reptiles might have slowed or perished. Hatchlings may have hatched during bright summers, growing strong before the darkness returned. Picture a herd of feathered herbivores moving through a shadowed forest under starlit skies. Snow crunching beneath their feet. Predators moving silently nearby. This world was not frozen and lifeless. It was alive in darkness, with dinosaurs thriving through long polar nights. Duck hadrosaurs, the duck-billed grazers. Among the most successful dinosaurs were the hadrosaurs, often called duck-billed dinosaurs. Their broad, flat snouts looked like beaks, perfect for cropping plants. Inside their jaws were hundreds of teeth arranged in complex dental batteries that worked like natural grinding machines. They sliced leaves, crushed stems, and processed tough vegetation with remarkable efficiency. Some grew over 30 feet long and traveled in large herds, grazing across floodplains like prehistoric herds of bison or wildebeest. But hadrosaurs were more than grazers. Many had elaborate crests, ridges, and skull shapes that made them some of the most visually striking dinosaurs ever discovered. Their strange silhouettes turned them into living sculptures of evolution. The duck-billed nickname may sound gentle, but hadrosaurs were among the most advanced herbivores of their time, shaping ecosystems across continents. Musical notes dinosaurs that sang across the plains. The hollow crests of some hadrosaurs were not just decoration. They were acoustic chambers. Species like Parasaurolophus likely used these structures to produce deep, resonant calls that traveled across great distances. Imagine a floodplain at dusk. A hadrosaur lifts its head and releases a low, echoing sound that rolls across the landscape. Others answer, their voices blending into a prehistoric chorus. The air vibrates with sounds deeper than any human voice. Computer simulations suggest these calls may have sounded like foghorns or deep musical instruments. They could have been used to warn of predators, attract mates, or maintain contact within herds. For the first time, dinosaurs are not silent fossils. They are voices in the ancient wind. Trumpet the spectacular crest of Parasaurolophus. Parasaurolophus carried one of the most extraordinary features in dinosaur evolution. Its crest stretched up to 6 feet long, curving elegantly backward like a natural trumpet. Inside, twisting air passages connected to the nasal cavity, allowing it to create complex and haunting sounds. The crest may also have been a visual display. Its size and shape could have signaled strength, health, or social status. Some scientists imagine it painted in bright colors, making the dinosaur a living banner moving across the plains. Standing nearly 30 feet long, Parasaurolophus was already impressive. With its towering crest, it became a creature of both sight and sound, a prehistoric musician broadcasting its presence across ancient landscapes. Milky Way hearing beyond human sound. Dinosaurs likely experienced a world of sound very different from ours. Some may have been able to hear in infrasonic ranges, frequencies too low for humans to detect. These deep vibrations travel long distances through air and ground, making them perfect for communication. Imagine dinosaurs calling to each other across miles with rumbling tones felt more than heard. Herds coordinating movement, mothers calling young, warnings spreading through the ground like ripples through water. Elephants and whales use infrasound today, and dinosaurs may have shared this hidden language. Their world was not just seen, but felt through vibrations beneath their feet. DNA skin, scales, feathers, and quills. Occasionally, fossils preserve something extraordinary, skin impressions. These rare finds reveal that dinosaurs were covered in a stunning variety of textures. Some had reptilian scales arranged in intricate patterns. Others had soft feathers or stiff quills rising from their skin. These impressions tell us dinosaurs were not uniform. They were patterned, textured, and diverse. Imagine brushing your hand along the scaly hide of a hadrosaur, then touching the soft plumage of a feathered theropod. These traces collapse millions of years into a tangible moment, letting us see dinosaurs as living creatures, not just bones and stone. Rainbow colors, crests, and courtship. Many dinosaurs likely displayed bright colors on frills, crests, and horns. These features may have been used in courtship displays or social signaling. Picture a ceratopsian with a wide frill glowing with reds and blues, or a hadrosaur crest shimmering in sunlight. These dinosaurs may have performed rituals, displays, and competitions just like modern birds and mammals. Evolution does not only build for survival. It builds for beauty, communication, and spectacle. Dinosaurs were part of that tradition, ancient, vibrant, and expressive in ways we are only beginning to understand. Artist palette colors lost in stone. Fossil evidence shows intricate networks of blood vessels running through dinosaur frills and crests. These vessels once carried nutrients to living tissue, supporting vibrant pigments and dynamic displays. In the silent fossil record, those colors are gone, washed away by time, pressure, and mineralization. But imagining them restores life to stone. It reminds us that dinosaurs were not just survivors shaped by nature, but living canvases of evolution. They lived in a world where color mattered, where beauty, display, and visual storytelling played a role in survival. The prehistoric world was not dull or muted. It was alive with color, motion, and spectacle, a planet painted by evolution itself. T-Rex Carnotaurus and the mystery of tiny arms. Carnotaurus was one of the strangest predators to ever roam Earth. Its skull carried sharp horns above its eyes, giving it a fierce and almost mythical appearance. Its body was sleek, built for speed, with long legs designed for pursuit. Yet its arms were astonishingly small, so short and stiff that scientists still debate their purpose. Unlike Tyrannosaurus rex, whose arms were muscular and flexible, Carnotaurus limbs were rigid and almost immobile. They may have played a role in mating displays, balance, or communication. Or they may simply have been evolutionary remnants, shrinking as other traits became more important. Despite this oddity, Carnotaurus was no weakling. It was fast, agile, and deadly, capable of chasing down prey with terrifying efficiency. Its tiny arms remind us that evolution is not about perfection. It is about trade-offs, experiments, and strange solutions that sometimes defy intuition. Flex biceps Tyrannosaurus, small arms, hidden strength. The arms of Tyrannosaurus rex are often mocked in popular culture, but they were far from useless. Each arm, though short, was packed with muscle and capable of lifting hundreds of pounds. The claws were sharp and strong, suited for gripping, slashing, or holding prey. Their small size may have been an advantage. Positioned close to the body, they were protected from injury during violent hunts dominated by the massive jaws. Rather than being evolutionary mistakes, these arms were likely specialized tools designed for a specific role in the T-Rex's hunting strategy. What seems ridiculous at first glance often hides a deeper purpose. Tyrannosaurus arms are a reminder that nature builds with intention, even when the design looks unusual. Eggoviraptor, from egg thief to devoted parent. The name oviraptor means egg thief. When its fossils were first discovered near clutches of eggs, scientists assumed it was raiding nests. But later discoveries revealed a completely different story. Oviraptor was not stealing eggs. It was protecting them. Fossils show adults preserved in brooding positions, wings spread over nests like modern birds incubating their young. Some were buried in protective postures during storms, refusing to abandon their eggs even in death. This revelation transformed Oviraptor from villain to guardian. It showed that dinosaurs could be devoted parents, caring for their offspring with dedication and sacrifice. Their world was not just filled with predation and struggle, but with tenderness and family bonds. Dinosaurs that brooded like birds. Oviraptor was not alone. Several dinosaur species have been found fossilized while brooding nests, their bodies curled protectively over eggs, forelimbs spread in unmistakably bird-like poses. These fossils provide some of the strongest evidence linking dinosaurs to birds. Some species may have rotated their eggs, regulated nest temperature, or defended hatchlings. These behaviors, once thought uniquely avian, stretch deep into dinosaur ancestry. Imagine a feathered dinosaur crouched over a nest, feathers puffed against the wind, eyes alert to danger. This scene feels surprisingly modern, echoing through time to every nest built by birds today. Dinosaurs were not just beasts of scale and power. They were caretakers, guardians, and parents. Toothed hatchlings with temporary teeth. Dinosaur babies were not miniature adults. Fossils of hatchlings reveal that some were born with sharp temporary teeth that disappeared as they grew. These teeth may have helped them break through eggshells or eat different foods during early life stages. As they matured, their jaws transformed to suit adult diets. A hatchling that once nipped insects or soft plants might grow into a massive herbivore grinding tough vegetation. This dramatic transformation shows that evolution shapes not only species across millions of years, but individuals across their lifetimes. Dinosaurs changed as they grew, their bodies adapting step by step from fragile newborns to giants of their world. Rocket growth at an unimaginable speed. Some dinosaurs grew at astonishing rates. Bone studies reveal growth rings, showing that certain species gained dozens of pounds per day. A tiny hatchling could become a multi-ton giant in just a few years. Imagine a young sauropod starting life no bigger than a dog, growing to the size of a horse within a year. and then expanding into a creature longer than a bus. Their bodies were biological engines, converting massive amounts of food into muscle and bone. Rapid growth was a survival strategy. The faster they grew, the sooner they could escape predators and dominate their ecosystems. Dinosaurs were not just large. They were fast-growing, fast-living titans. Rainbow dinosaurs in a rainbow of colors. For decades, dinosaurs were imagined in dull greens and browns. But fossil discoveries have revealed a much more vibrant reality. Microscopic pigment structures called melanosomes preserved in feathers allow scientists to infer ancient colors by comparing them to modern birds. The results are astonishing. Dinosaurs displayed blacks, reds, oranges, browns, whites, and even shimmering iridescent hues. Some likely glowed with metallic blues and greens like hummingbirds. Others bore fiery copper tones or bold patterns. The prehistoric world was not a muted landscape. It was a living rainbow, filled with shimmering feathers and patterned skins moving through forests and plains. Microscope fossils that preserve color. Some fossils preserve pigment structures so clearly that scientists can reconstruct patterns. Certain dinosaurs had black feathers with bright orange tips. Others shimmered with iridescent colors like modern starlings or crows. One Chinese species showed a striking black and white body with a rusty red crown, more like a modern bird than a reptile. These discoveries collapse the distance between past and present, letting us see dinosaurs as living creatures, not just bones. Imagine sunlight filtering through prehistoric forests, catching flashes of iridescent feathers as dinosaurs moved through branches. Their colors were not just decoration. They were communication, camouflage, and evolutionary storytelling. Herb masters of camouflage. Some dinosaurs used color not to stand out, but to disappear. Fossil evidence suggests striped and mottled patterns on certain species, similar to camouflage in modern animals. These patterns help them blend into forests, grasslands, and shadows. Just as tiger stripes break up their outline today, dinosaur patterns may have hidden them from predators or prey. Even massive herbivores may have used subtle patterns to soften their silhouettes in dappled forest light. Evolution paints with both brightness and invisibility. Dinosaurs mastered both, becoming artists of survival in a world of color and shadow. Performing arts patterns that spoke without words. Imagine a small dinosaur crouched in leaf litter, its striped body dissolving into shadow until it suddenly darted forward to seize prey. Camouflage tells us that dinosaurs didn't rely solely on brute strength or heavy armor. Many survived through subtlety, patience, and invisibility. In the prehistoric world, color was not just decoration. It was survival. A pattern could mean the difference between becoming a meal or escaping unnoticed. Stealth painted in stripes and shadows was as powerful as claws and teeth. But camouflage was only half the story. Rainbow colors that dazzled and dominated. Some dinosaurs likely wore bold, contrasting patterns meant to intimidate rivals or attract mates. Nature today shows us how powerful visual signals can be. A peacock's tail, a bird of paradise dance, or a sudden flash of wings can command attention instantly. Imagine a ceratopsian raising its massive frill, painted in radiant blues, reds, and yellows, transforming itself into a living banner of dominance. Picture a feathered raptor spreading its arms, revealing bright hidden patterns that startled prey or warned competitors. Fossils give us hints, pigment traces, vascular patterns, and structural clues, but much remains unseen. Still, the evidence suggests a prehistoric world filled with visual drama, where dinosaurs were not just animals, but living artworks shaped by evolution's imagination. Shield ceratopsian frills, identity in bone. Ceratopsians like Triceratops wore enormous frills extending from the back of their skulls. While these structures may have offered some defense, many were thin, ornate, and riddled with openings, making them less useful as shields and more suited for display. Scientists believe these frills acted as social signals, indicating species identity, age, health, and dominance. Each species carried its own unique frill shape, like a signature carved into bone. Imagine a vast plain filled with ceratopsian herds, each animal's frill flashing like a living flag, broadcasting who they were and where they belonged. In this world, bone itself became language. Brain pachycephalosaurs, heads built like weapons. Among the strangest dinosaurs were the pachycephalosaurs, crowned with thick domed skulls. These domes could be over 10 inches thick, dense, reinforced, and often surrounded by spikes and knobs. For years, scientists debated their purpose. The leading theory is that these domes were used in head-to-head contests, much like rams or bighorn sheep today. Imagine two pachycephalosaurs charging across a clearing, their skulls colliding with a thunderous crack. The shock waves ripple through the forest. The thick bone absorbs the impact, turning the head itself into a living battering ram. Evolution had transformed their skulls into tools of dominance, spectacle, and survival. Cross-swords ritual battles written in bone. Fossils reveal healed injuries and damage on pachycephalosaur skulls, supporting the idea that these dinosaurs engaged in frequent headbutting contests. These battles likely decided territory, social rank, and mating rights. Some encounters may have been ritualistic displays, head tilts, posture changes, and slow-motion standoffs. Others may have been violent clashes, echoes of prehistoric competition resounding through forests and plains. These fossil scars are silent witnesses to ancient rivalries, showing that dinosaurs lived complex social lives filled with conflict, hierarchy, and display. Counterclockwise arrows button horns that could heal. Horns were among the most striking dinosaur features, from Triceratops spears to the ornate headgear of other ceratopsians. Fossil evidence suggests that some dinosaurs could regenerate damaged horns, repairing fractures over time. In a world where horns were used in combat, defense, and display, this ability would have been invaluable. A broken horn didn't mean the end of dominance. It could grow back, ready for the next confrontation. Imagine two horned giants locking in battle, one horn snapping, only for it to slowly return over months or years. Evolution had given them not just weapons, but the power to repair those weapons. Dagger raptors and the sickle claw. Raptors carried one of the most iconic weapons in natural history, a sickle-shaped claw on each hind foot. This claw was held off the ground to keep it razor sharp, ready for combat. Imagine a raptor leaping forward, gripping prey with its forelimbs while driving that curved blade downward. The design was elegant and lethal, perfectly shaped for slashing and gripping. Size was irrelevant. Precision, agility, and a single curved claw were enough to make raptors terrifying predators in their ecosystems. Microscope natural knives sharper than steel. Fossilized raptor claws reveal where patterns consistent with slicing motions. When fresh, these claws would have been sharper than many human-made blades. Picture a predator with knives strapped to its feet, capable of leaping, slashing, and pinning prey in seconds. Some scientists believe the claws were used not just for killing, but for holding prey in place while the jaws delivered the final blow. Evolution had forged natural weapons millions of years before humans ever imagined metal blades. T-Rex Giganotosaurus, a rival to T-Rex. For decades, Tyrannosaurus rex was seen as the undisputed king of predators. But discoveries in South America revealed a challenger, Giganotosaurus. This giant predator stretched over 40 feet long, possibly longer than T-Rex. Its skull alone was over 5 feet long, filled with blade-like teeth designed for slicing rather than crushing. Imagine a predator the length of a bus stalking across ancient Patagonia, hunting massive herbivores like Argentinosaurus. Unlike T-Rex's bone-crushing bite, Giganotosaurus specialized in cutting flesh, relying on speed and teamwork to take down giants. Its discovery showed that Earth produced multiple apex predators, each with different hunting strategies. T-Rex was iconic, but it was not alone. Globe showing Europe, Africa, Argentinosaurus, the titan of titans. Among all land animals that have ever lived, few rival Argentinosaurus. This colossal titanosaur may have stretched over 100 feet long and weighed more than 70 tons. Imagine a creature longer than a basketball court, its footsteps shaking the ground, its shadow stretching across forests and plains. Its heart alone may have been the size of a small car, pumping blood through a body built on a scale almost unimaginable today. To survive at such size, Argentinosaurus needed constant food, massive lungs, and a circulatory system powerful enough to deliver oxygen to every cell. It was a walking ecosystem, a living mountain shaped by evolution's ambition. When predators like Giganotosaurus approached, they didn't face an animal. They faced a moving landscape of muscle, bone, and life. Snow-capped mountain living mountains that walked. Its bones were so massive that a single vertebra could weigh more than a human. Yet despite their immense bulk, these giants survived not as solitary titans, but as social travelers. Herds of Argentinosaurus moved together across ancient plains, stripping vast amounts of vegetation as they journeyed. Their necks reached into treetops, plucking leaves that no other land animal could reach. Their tails swayed behind them like living bridges, balancing their colossal bodies. Every step sent tremors through the ground, vibrations that smaller animals could feel from miles away. To witness an Argentinosaurus in life would have been like watching a mountain decide to walk. A moving landscape of muscle and bone, reshaping forests simply by passing through them. Their existence shows how far evolution can push the limits of size, stretching biology to the edge of what land can support. Mouse-faced dinosaurs smaller than a mouse. Not all dinosaurs were giants. In fact, some were astonishingly tiny. The smallest known dinosaurs, like Microraptor and even tinier relatives, weighed less than a modern mouse. Some were no longer than a human hand, darting through branches and leaf litter in search of insects. Their delicate skeletons, feathered bodies, and lightweight frames reveal a hidden world of miniature dinosaurs living alongside giants. These small creatures may have lived fast, frantic lives, avoiding massive predators while competing with early mammals and reptiles for food. Imagine crouching in a prehistoric forest and noticing a flicker of movement. A tiny feathered creature no bigger than a sparrow, eyes bright, claws sharp, vanishing into the shadows. Evolution is not only about becoming large and powerful. Sometimes survival means staying small, agile, and unnoticed. Dinosaurs existed in every size imaginable, from living mountains to feathered whispers in the undergrowth. Pawprints dinosaurs and the first mammals. Dinosaurs dominated the Mesozoic, but they did not rule alone. Beneath their feet, small mammals scurried through burrows and forests, living in the shadows of giants. These early mammals were often nocturnal, surviving by eating insects, hiding underground, and avoiding attention. For over 100 million years, mammals and dinosaurs coexisted. Some mammals laid eggs, others bore live young, and some evolved surprising adaptations that helped them persist in a world ruled by reptiles. Imagine a Mesozoic night. The forest echoes with distant roars and heavy footsteps. Above, dinosaurs move through darkness. Below, tiny furry creatures slip through ferns and roots, building the lineage that would one day inherit the earth. Giants above, survivors below, two worlds intertwined in quiet balance. Rat when mammals hunted dinosaurs. While most mammals were small and cautious, some were bold predators. Fossils have revealed tiny mammals with dinosaur bones in their stomachs, evidence that they preyed on hatchlings. These mammals likely raided nests, targeting newly hatched dinosaurs before they could grow large enough to defend themselves. Imagine a small mammal, no bigger than a house cat, slipping into a nest, snatching fragile hatchlings and disappearing into the night. Even the rulers of Earth had vulnerable beginnings. Dinosaurs may have dominated, but their young were not invincible. Ecosystems are complex, and power flows in unexpected directions. Cherry blossom dinosaurs and the rise of flowers. The age of dinosaurs was also the age of botanical revolution. Around the mid-Cretaceous, flowering plants began to spread. Before them, forests were dominated by ferns, conifers, and cycads. Flowers brought new colors, scents, and reproductive strategies. Dinosaurs walked through landscapes that were slowly blooming into something new. Herbivores fed on early blossoms, while plants evolved alongside animals that helped spread their pollen and seeds. Imagine a hadrosaur grazing among cycads, lifting its head to pluck fragrant flowers, scattering petals across the forest floor. The first gardens of Earth were growing, and dinosaurs were their gardeners and guests. Blossom a planet in bloom. By the end of the Cretaceous, flowering plants dominated much of the world. Forests and plains were filled with blooms, fruits, and seeds. This botanical revolution reshaped dinosaur diets and entire ecosystems. Small dinosaurs and early birds likely played roles in spreading seeds and pollen. Insects buzzed among flowers, creating complex food webs that still exist today. Picture a Cretaceous landscape glowing with color. Flowers underfoot, insects in the air, dinosaurs moving through fields of blossoms. The world was becoming something recognizably modern, long before humans arrived. Bird dinosaur pollinators. If flowers rose during the dinosaur age, some dinosaurs likely helped them spread. Small feathered dinosaurs and primitive birds may have carried pollen as they fed on nectar-like substances and fruits. Imagine a tiny feathered dinosaur hopping from flower to flower, dusted in pollen, unknowingly performing the same role as a hummingbird. Plants offered food, and dinosaurs carried their genetic legacy across landscapes. Evolution is not only competition, it is cooperation across species and eras. Flowers and dinosaurs shaped each other in silent partnership. Globe showing Europe-Africa methane and the dinosaur climate. It may sound humorous, but research suggests dinosaurs, especially giant sauropods, produced enormous amounts of methane through digestion. Like cows today, plant-eating dinosaurs relied on gut bacteria to break down fibrous plants, releasing methane as a byproduct. Given their size and numbers, this gas may have influenced Earth's climate, contributing to the warm greenhouse conditions of the Mesozoic. Imagine vast herds grazing across plains, their collective digestion subtly altering the atmosphere itself. Dinosaurs were not just shaped by climate. They helped shape it. Their breath, their movement, and yes, even their digestion may have influenced the planet's temperature. Seedling dinosaurs as gardeners of the ancient world. Dinosaurs did not just eat plants. They helped spread them. Fossilized dung, known as coprolites, sometimes contains seeds, showing that dinosaurs swallowed seeds and deposited them far away. In this way, dinosaurs acted as gardeners, carrying plants across continents. A giant sauropod wandering across plains left behind not just footprints, but future forests growing from its droppings. This mutual relationship between plants and dinosaurs mirrors modern ecosystems. Plants fed dinosaurs, and dinosaurs helped plants expand. Evolution often grows through quiet partnerships. Fork and knife with plate fossils of the last meal. Sometimes fossils preserve more than bones. Rare discoveries reveal dinosaur stomach contents, frozen in time. These fossils show partially digested plants and animals, offering a direct glimpse into daily life. We can see what dinosaurs ate, where they lived, and how ecosystems functioned millions of years ago. These preserved meals are time capsules, whispering stories from vanished worlds. Imagine discovering a fossil that still holds leaves from a forest that no longer exists, or the bones of prey swallowed millions of years before humans walked the earth. Bone fossils of the last hunt. Others contain fish bones, small reptiles, or even other dinosaurs frozen mid-digestion. These rare snapshots are invaluable. They show not just what dinosaurs could eat, but what they truly ate in their daily lives. One famous fossilized microraptor, for example, preserved the remains of a bird in its stomach, proving it was a nimble predator capable of hunting in trees. These time capsules let us peer into private moments of survival, when hunger drove action and instinct shaped behavior. It is humbling to realize that a single meal can last for tens of millions of years, quietly telling the story of an ordinary day in the deep past. Pilafpu, the science of coprolites. Fossilized dung is called coprolite. It may sound unglamorous, but these ancient droppings are among the most fascinating fossils ever discovered. Over time, waste hardens into stone, preserving tiny fragments of food inside. Seeds, shells, bones, and plant fibers become locked in place, turning dung into a prehistoric diary of diet and ecosystem. By studying coprolites, scientists learn how food chains were structured, what kinds of plants grew in certain regions, and even how dinosaur digestion worked. Some coprolites are small and delicate. Others are massive, weighing dozens of pounds. Coprolites remind us that no trace of life is too humble to matter. Even waste becomes treasure when it carries secrets from a vanished world. Through these unlikely fossils, dinosaurs still whisper stories to us in the most unexpected way. Brick, a 40-pound fossilized pile. One of the largest known coprolites weighs more than 40 pounds. Scientists believe it may have come from a massive predator, possibly Tyrannosaurus rex. Inside, they found fragments of bone, proving the animal consumed huge amounts of prey. These discoveries are astonishing. They reveal how much food dinosaurs ate, how powerful their digestive systems were, and how efficiently they processed massive meals. It is almost humorous to imagine such a colossal creature leaving behind such an enormous pile. But to paleontologists, it is a goldmine of data. Even the waste of giants became part of the fossil record, preserved as a monument to life's most basic processes. Dinosaurs that swallowed stones. Some dinosaurs swallowed stones to help grind their food. These stones, called gastroliths, acted like internal grinding tools. Without chewing teeth like ours, plant-eating dinosaurs needed another way to break down tough leaves and stems. Inside their muscular stomachs, these stones tumbled and crushed vegetation into digestible pulp. Fossils have been found with clusters of polished stones inside the rib cages of sauropods and other herbivores. Over time, the stones became smooth and rounded from constant grinding. Imagine a massive sauropod grazing peacefully, relying on a handful of swallowed rocks to process its meal. Evolution often finds clever solutions with simple tools. River stones became part of the digestive machinery of some of the largest animals ever to live. Gear nature's internal millstones. The term gastrolith comes from Greek, meaning stomach stone. These stones have been found not only in dinosaurs, but also in prehistoric marine reptiles and even modern birds. Their polish and wear patterns prove they were swallowed deliberately, not by accident. In some fossils, dozens or even hundreds of gastroliths sit like a small rock collection within the skeleton. Scientists can sometimes trace where the stones came from, revealing where dinosaurs may have traveled. Today, birds still use gastroliths, creating a direct evolutionary link across deep time. These humble stones remind us that nature often reuses successful strategies. Gastroliths were nature's internal millstones, quietly grinding life into fuel inside the bellies of giants. Giraffe necks longer than a giraffe's body. Among the sauropods, evolution created necks of staggering length. Some stretched over 30 feet, longer than an entire giraffe. These colossal necks allowed sauropods to feed high in treetops or sweep wide areas of ground vegetation without moving their massive bodies. The engineering behind these necks is extraordinary. Lightweight, air-filled bones reduced weight, while powerful muscles and tendons supported movement. Blood vessels worked tirelessly to pump oxygen to brains perched high above the ground, posing puzzles scientists still study today. Imagine standing beneath a sauropod's head, craning upward as it towers stories above you, calmly plucking leaves with movements both graceful and immense. These necks turned sauropods into living skyscrapers, redefining what it meant to be large on land. Puzzle piece: the vertebrae that built giants. The secret to these long necks lies in their vertebrae. Humans have only 7 neck vertebrae, but many sauropods had 15 or more. Each vertebra was elongated, hollow, and intricately shaped, reducing weight while maintaining strength. These bones were filled with air sacs, creating a structure both light and durable. Ridges and hollows provided attachment points for muscles and ligaments, allowing flexibility across enormous distances. Some vertebrae even locked together to stabilize the neck while still allowing sweeping motion. Imagine the neck of a diplodocus stretching across a city street, each vertebra part of a chain engineered by evolution. Nature built unimaginable structures by repeating and extending simple units, turning bone into architecture. Shield-armored giants. While many sauropods were relatively unarmored, titanosaurs added protection. Their skin was studded with osteoderms, bony plates embedded beneath the surface like natural armor. These plates ranged from small nodules to large shields several inches across. They may have deterred predators or served as visual displays, catching the light as the giants moved. Picture a creature longer than a basketball court, its hide glinting with embedded armor under the sun. These osteoderms connect titanosaurs to other armored reptiles, showing how evolution repeatedly returned to bony skin as a defense strategy. For titanosaurs, armor added resilience to bodies already pushed to biological extremes. They were not just giants, they were living fortresses. Herb necks like giant vacuum hoses. Not all sauropods held their necks upright like giraffes. Some, like Diplodocus, likely held their necks horizontally, sweeping them side to side like enormous vacuum hoses. This posture allowed them to strip wide areas of vegetation without moving their heavy bodies. Imagine a Diplodocus standing still while its 30-foot neck glides across a meadow, jaws plucking ferns and leaves in slow, graceful arcs. This feeding strategy turned the neck into a living scythe, harvesting prehistoric forests. The contrast between upright-necked giants like Brachiosaurus and horizontal feeders like Diplodocus shows how evolution allowed multiple giants to coexist by dividing resources. Their necks were not just long, they were specialized tools shaped for different ecological roles. Cityscape: a 5-story dinosaur. Among the tallest dinosaurs was Brachiosaurus, a creature whose head could rise higher than a 5-story building. Its front legs were longer than its back legs, tilting its body upward like a living crane. This posture allowed it to reach treetops that no other land animal could touch, feeding in a vertical world untouched by other herbivores. Imagine standing in a prehistoric forest as a Brachiosaurus lifts its head into the canopy, gently plucking leaves while sunlight filters through its massive silhouette. Brachiosaurus did not just walk on Earth. It towered above it, a living skyscraper shaped by evolution to touch the sky. Cityscape: a living skyscraper in the Jurassic. This unique posture gave Brachiosaurus a towering presence, allowing it to browse leaves no other herbivore could reach. Imagine walking through a Jurassic forest and looking up to see this colossal giant calmly feeding far above you, its head disappearing into the canopy like a moving cloud among the treetops. Fossils suggest its size was matched by immense strength. Its heart had to pump blood with incredible force to push it upward through its long neck to its elevated brain. Standing beside one would have felt like standing at the base of a living building, except this building breathed, moved, and grazed peacefully among the trees. Its sheer height made it one of the most breathtaking creatures of the Mesozoic era. A walking skyscraper of flesh and bone, shaped by evolution to reach into the sky and harvest the forest from above. Nose nostrils in the sky. Some dinosaurs had nostrils high up on their heads. Brachiosaurus and several other sauropods had nostrils positioned near the top of their skulls, rather than at the front of the snout like most animals today. For decades, scientists imagined these giants wading through rivers like enormous hippos, using their elevated nostrils like snorkels. That idea has mostly fallen out of favor, but the placement remains a fascinating mystery. It may have helped them breathe more easily while feeding high vegetation, or served as a resonating chamber for deep calls that traveled across prehistoric landscapes. Some scientists even speculate that these nostrils could inflate during vocalizations or social displays, turning the skull into a natural sound amplifier. Imagine a brachiosaurus lifting its head toward the sky, nostrils flaring as it released a deep rumbling call that rolled across forests like distant thunder. Even small anatomical details can carry enormous mysteries. Each feature is a clue to lives lived in ways we are still trying to reconstruct, piece by piece, from ancient stone. T-Rex, the twin-crested predator. Dilophosaurus, an early Jurassic predator, was distinguished by its twin crests rising from its skull. These thin, delicate structures were likely too fragile for combat, suggesting they served as visual displays rather than weapons. Brightly colored crests could have signaled health, dominance, or readiness to mate. Fossils show Dilophosaurus was about 20 feet long, one of the largest predators of its time. Imagine its silhouette against the dawn sky, twin crests catching the first sunlight as it called to rivals or potential mates, its shadow stretching across the ancient landscape. The crests turned this predator into a living symbol of evolutionary artistry, balancing deadly jaws with elegant ornamentation. It didn't need extra weapons to stand out. Evolution had already given it a striking signature. Clapperboard Hollywood versus reality. It probably didn't spit venom like in Jurassic Park. The movie famously portrayed Dilophosaurus as a small, frilled, venom-spitting monster. While terrifying on screen, there is no fossil evidence for venom glands or frills in this species. In reality, Dilophosaurus was larger, faster, and relied on jaws and agility rather than chemical weapons. The cinematic version was pure fiction designed for dramatic effect. Yet the myth persists, making Dilophosaurus one of the most misunderstood dinosaurs in popular culture. The real animal, with its twin crests and predatory build, was already extraordinary. Its story reminds us how science and cinema can diverge, but also how reality often holds its own kind of wonder, quieter yet deeper. Raptors were feathered. Velociraptors didn't look like they do in the movies. The sleek, scaly raptors of Jurassic Park are iconic, but they are not accurate. True velociraptors were small, turkey-sized predators covered in feathers. Fossils from Mongolia reveal quill knobs on their arms, the same structures that anchor feathers in modern birds. These feathers likely helped with balance, insulation, and display rather than flight. Imagine a velociraptor darting through underbrush, feathers ruffling in the wind, moving with bird-like grace and precision. Its size was modest, but its intelligence and agility made it a formidable hunter. The feathered truth transforms raptors from reptilian monsters into bird-like predators, bridging the gap between dinosaurs and modern birds. Far from making them less frightening, this makes them feel eerily familiar, like predators from another time that still echo in the wings of birds today. Speaker high volume, the voice of T-Rex. Tyrannosaurus Rex likely didn't roar. The iconic cinematic roar is a Hollywood invention. Fossils cannot preserve sound, but comparisons with modern birds and crocodiles suggest something far stranger. Instead of roaring like a lion, T-Rex may have produced deep, resonant rumbles or low-frequency infrasound that traveled great distances and could be felt as vibrations. Such sounds would carry through forests and across plains, announcing presence without the need for loud calls. Imagine standing on a Cretaceous plain as the ground subtly trembles, a low hum passing through your chest before you see the predator itself. A sound felt more than heard, a presence that arrived before sight. The silence of fossils leaves us guessing, but evidence suggests the voice of T-Rex was not loud and dramatic, but deep, haunting, and unforgettable. Footprints of giants. Some dinosaur footprints stretch over 3 feet wide. These colossal impressions pressed deep into ancient mud mark the passage of creatures weighing tens of tons. Standing inside one today is like stepping into the shadow of a ghost. Many belong to sauropods, their massive feet spreading weight across broad surfaces. Others show the clawed toes of giant theropods, each print recording power and motion. Footprints bring dinosaurs to life in ways skeletons cannot. They reveal how heavy they were, how fast they walked, and how their toes interacted with the earth. To see one is to stand exactly where a giant once stepped, bridging millions of years with a single footprint. Person-running fossilized movement. Trackways reveal dinosaurs running, resting, and even sliding. Some tracks show long, spaced strides that indicate sprinting at surprising speeds. Others preserve resting poses where dinosaurs crouched low, leaving impressions of bellies, tails, and hands. In rare cases, sliding marks suggest animals skidding on muddy slopes or interacting playfully with wet ground. These trackways are dynamic fossils, frozen moments of movement that transform stone into motion. Imagine a muddy riverbank where a dinosaur slipped, claws scraping the ground, leaving marks that hardened into stone. These details turn fossils into stories of living moments, not just static bones. Family woman girl family tracks. Some trackways show mother dinosaurs walking with babies. Large footprints accompanied by smaller ones suggest parents guiding and protecting their young. Juvenile tracks often stay close to adult prints, showing dependence and care. In some sites, groups of tracks suggest coordinated family movement, with adults surrounding juveniles for protection. Imagine a Cretaceous plain where a mother dinosaur leads her young across soft mud, each step preserved forever. Millions of years later, those tracks still tell a story of care and connection. Written not in words, but in paths pressed into stone by walking feet. Globe showing Europe, Africa, 8,000 species, and counting. There are over 1,000 known dinosaur species, and new ones are discovered almost every year. From tiny bird-like predators no bigger than a pigeon to the largest animals ever to walk the land, dinosaurs filled every ecological niche. They lived in forests, deserts, plains, and wetlands. Some were armored, some feathered, some horned, others crested or sail-backed. Their diversity reveals how incredibly successful they were, thriving on every continent for more than 160 million years. Each species was a unique experiment by evolution, testing new forms, new behaviors, and new ways to survive. Dinosaurs were not a single story. They were a vast library of living designs, each chapter written in bone, feather, and fossilized time. Volcano, the unfinished catalog of life. And the list is far from complete. Countless dinosaur species remain undiscovered, their fossils still locked deep inside rock layers, waiting for erosion, excavation, or pure chance to reveal them. Imagine all the forms we haven't yet seen, colors, shapes, behaviors, and adaptations beyond anything we've dreamed. Dinosaurs were not just giants towering over landscapes. They were an endlessly diverse tapestry of life woven across deep time, each thread representing a unique evolutionary experiment. Some were feathered, some armored, some graceful, others monstrous. And many are still unknown, sleeping in stone beneath deserts, forests, and mountains. Every undiscovered fossil is a message from deep time, waiting to be translated. The age of dinosaur discovery is far from over. In many ways, it has only just begun. Microscope a new dinosaur every month. New species are discovered almost every month. With modern technology, CT scanning, satellite imaging, and advanced excavation tools, paleontologists continue to uncover dinosaurs at an astonishing pace. On average, a dozen or more new species are described every year, each one adding another piece to the vast puzzle of prehistoric life. Discoveries emerge from deserts, cliffs, and quarries around the world. From feathered raptors in China to colossal titanosaurs in South America, many finds rewrite what we thought we knew. Some dinosaurs had sails, others crests, others bizarre feeding structures or unexpected diets. Imagine brushing dust from a fossil that represents a creature no human has ever seen before. A species that walked, breathed, and lived millions of years ago, now meeting human eyes for the first time. Each new name etched into scientific history brings the ancient world back into focus. The story of dinosaurs is still unfolding, long after they vanished from Earth. Sheaf of rice fossils found by accident. Not every dinosaur discovery begins in a laboratory or organized expedition. Some of the most remarkable fossils have been found entirely by accident. Farmers plowing fields, construction workers digging foundations, hikers exploring remote terrain. Many have stumbled upon bones that turned out to be tens of millions of years old. In China, villagers once collected what they believed were dragon bones from riverbeds, only later realizing they were dinosaur fossils. In Canada, miners uncovered a fully preserved nodosaur, its armor and skin still intact, hidden for over 100 million years. These chance encounters remind us that Earth still holds countless secrets just beneath the surface. Every hillside, quarry, or dry riverbed could hide a portal to prehistory. Sometimes science doesn't begin with a research grant or a university team. Sometimes it begins with someone looking down and noticing something extraordinary. Person-standing giants before dinosaurs had a name. The first dinosaur fossils were mistaken for giant humans. Before the word dinosaur existed, people found enormous bones and tried to explain them with myths and scripture. In 17th century England, massive femur bones were believed to belong to legendary giants, echoes of biblical figures and folklore heroes. Huge teeth were attributed to elephants or unknown beasts. Skull fragments were thought to be remains of ancient warriors or monstrous humans. Without paleontology, imagination filled the gaps. It wasn't until the 19th century that scientists like Richard Owen recognized these bones belonged to an entirely different group of animals, creatures that lived long before humans existed. The realization reshaped science forever, expanding humanity's sense of time and history. Before they were dinosaurs, they were giants in the human imagination. Myths tried to explain what science had not yet named. Dragons in stone. Ancient cultures sometimes thought dinosaur bones were dragon remains. Dragon myths appear across cultures, from Europe to China, and many scholars believe fossil discoveries helped inspire these legends. In China, large fossilized bones were called dragon bones and ground into medicine. In Europe, massive vertebrae and skull fragments found in caves may have inspired tales of knights battling monstrous creatures. Imagine discovering a massive skull with razor-sharp teeth and no context to explain it. Without paleontology, what else could it be but a dragon? These bones fueled legends for centuries, blending science with myth long before science existed as we know it. In a way, dinosaurs never truly disappeared. They lived on in human imagination, shaping dragons, monsters, and myths. Dragons, it turns out, were real. We just call them dinosaurs today. Crossed swords the bone wars. Fossil hunters once fought wars over dinosaur bones. In the 19th century, two paleontologists, Othniel Charles Marsh and Edward Drinker Cope, became locked in a bitter rivalry known as the Bone Wars. They raced across the American West to discover new dinosaurs, sending teams to dig fossils at breakneck speed. Their feud was so intense that crews sometimes sabotaged each other's digs, destroying fossils rather than letting them fall into a rival's hands. Out of this chaos came over 100 new dinosaur species, including Triceratops, Stegosaurus, and Allosaurus. But the competition also led to mistakes, rushed conclusions, and broken fossils. The bone wars remain a cautionary tale of scientific rivalry, but also a reminder of passion. Without their obsession, paleontology might not have advanced as quickly. The dinosaurs became unwilling players in a very human battle for fame and legacy. Classical building a frenzy of discovery. Despite the chaos, the bone wars produced an astonishing flood of discoveries. Marsh and Cope named over 100 species in just a few decades. Many of the dinosaurs that fill museums today were first described during this era. Imagine walking into a 19th century museum and seeing towering skeletons of creatures no one had ever imagined. The public was stunned. Newspapers reported on these prehistoric giants like revelations from another world. For all its flaws, the Bone Wars ignited global fascination with dinosaurs and helped establish paleontology as a serious science. It was messy, dramatic, and imperfect, but it built the foundation of everything we know today. Crossmark mistakes in the rush. Some Bone Wars dinosaurs later turned out to be mistakes. In their rush to outdo each other, Marsh and Cope sometimes named species based on fragmentary fossils or misassembled skeletons. Some dinosaurs were duplicates of the same species. Others were reconstructed incorrectly. One famous mistake placed a sauropod's head on the wrong end of its body, creating a creature that never existed. Later scientists had to correct museum mounts and reclassify species. These errors didn't erase their contributions. Instead, they showed that science is a process, full of trial, error, and correction. Even mistakes push knowledge forward, revealing how understanding evolves over time. DNA soft tissue in stone. For decades, scientists believed only bones and teeth could survive millions of years. But in the early 2000s, a shocking discovery changed everything. Soft tissue structures were found inside dinosaur bones. Flexible structures resembling blood vessels and proteins were preserved inside fossils of Tyrannosaurus rex and other species. These findings challenged assumptions about fossilization and suggested that delicate tissues can survive under the right conditions. Imagine holding a fossilized bone and realizing that inside, hidden for over 60 million years, are traces of living tissue. Not just stone, but remnants of flesh, blood, and biology. Fossils were no longer just skeletons. They were molecular time capsules, test tube ancient proteins. Scientists have even recovered dinosaur proteins millions of years old. Collagen, a key component of connective tissue, has been identified inside fossilized bones. These molecules stretch the limits of what we thought could survive deep time. Analyzing them reveals clues about dinosaur physiology, growth rates, and evolutionary relationships. Protein comparisons show striking similarities between dinosaurs and birds, strengthening the evolutionary link suggested by feathers and skeletal anatomy. These discoveries do not mean dinosaurs can be resurrected like in science fiction, but they allow us to understand them in unprecedented detail at the molecular level. Fossils are not just relics of stone. Sometimes they still carry whispers of life, preserved against the odds for tens of millions of years. Puzzle piece, a molecular whisper across time. The survival of these molecules is almost miraculous, like discovering a voice preserved inside stone. It is not DNA, and we are nowhere near cloning dinosaurs, but it is a molecular fingerprint, a faint signature of life carried across 60 million years. These discoveries remind us that fossils are not just lifeless remnants. They are time capsules, some of them still holding the microscopic building blocks of once living creatures. Every preserved protein, every fragment of tissue, is a message from deep time, a whisper from organisms that lived, breathed, and vanished long before humanity appeared. To hold such a fossil is to touch the boundary between life and eternity, where biology meets geology and living matter becomes memory. Orange heart feathers frozen in amber. In the warm forests of the Cretaceous, sticky tree resin sometimes dripped onto dinosaurs, trapping feathers before hardening into amber. Millions of years later, these golden stones reveal breathtaking detail. Amber fossils from Myanmar preserve individual dinosaur feathers so delicate that their microscopic filaments are still visible. Some feathers even retain traces of pigmentation, revealing colors and patterns lost in stone fossils. These feathers belong to small theropods and early birds, offering direct proof that dinosaurs were often feathered, colorful, and dynamic creatures. Imagine holding a piece of amber and peering into it, seeing a feather that once caught the wind in a prehistoric forest. It feels like time folded in on itself, letting us glimpse a fragment of life frozen mid-moment. Amber preserves more than feathers. It traps insects, plants, and entire microecosystems, creating crystal-clear windows into the world dinosaurs actually lived in. It is not just a fossil. It is a preserved moment from an ancient afternoon, sealed in golden light. Drop of blood echoes of dinosaur blood. Even dinosaur blood cells may have been discovered. Under powerful microscopes, some fossils appear to contain structures resembling red blood cells, tiny disc-shaped imprints preserved within fossilized tissue. These discoveries are controversial and debated, but if confirmed, they represent some of the most intimate traces of dinosaur life ever found. The idea that microscopic echoes of dinosaur blood could survive tens of millions of years stretches the imagination. Scientists cannot extract DNA. That molecule is far too fragile to endure deep time. But even without DNA, the possibility that traces of blood remain is haunting. These cells once carried oxygen through veins, fueled muscles, and powered giants that thundered across ancient landscapes. Fossils are not just bones. They are memories etched into matter, preserving life down to its smallest scale. Comet the day the dinosaurs fell, globe showing Europe, Africa, a cosmic catastrophe. The reign of the non-avian dinosaurs ended in cataclysm. Around 66 million years ago, a massive asteroid struck Earth, unleashing devastation on a planetary scale. In a single moment, the age of dinosaurs, rulers of the planet for more than 160 million years, came to an abrupt and violent end. This event reshaped the course of life, erasing giants and clearing the stage for mammals to rise. The asteroid impact stands as one of the most dramatic turning points in Earth's history. Imagine a sudden flash brighter than the sun, followed by shock waves, firestorms, and oceans rising into towering walls. In mere days, the world was transformed. The dinosaurs' era did not fade quietly. It ended in a cosmic collision that silenced their dominion forever. Waterwave the crater beneath the sea. The asteroid struck what is now the Yucatan Peninsula, forming the Chicxulub crater beneath the Gulf of Mexico. More than 100 miles wide, this hidden scar is the silent footprint of catastrophe. Geological evidence matches the crater precisely with the mass extinction event. At the moment of impact, rock vaporized, oceans boiled, and the crust of Earth trembled. Today, the crater lies buried beneath sediment, invisible from the surface, yet unmistakable in seismic scans. It is a monument to destruction, proof that one cosmic event reshaped the destiny of life on Earth. Collision energy beyond imagination. The energy unleashed by the Chicxulub impact defies comprehension. Scientists estimate it equaled the power of several billion atomic bombs detonated at once. Shock waves raced around the globe, triggering earthquakes, volcanic eruptions, and global tsunamis. The air superheated, igniting wildfires across continents. Imagine standing thousands of miles away and still feeling the heat, seeing the sky rain molten rock. The event was not local. It was planetary. In a single moment, Earth's atmosphere, oceans, and land were altered forever. Waterwave skyscraper-high tsunamis. Because the asteroid struck shallow ocean, unimaginable volumes of water were displaced. Tsunamis taller than skyscrapers raced outward at jetliner speeds. Waves hundreds of feet high slammed into coastlines, tearing forests apart and sweeping creatures far inland. Sediment layers around the world still carry evidence of these colossal floods. Imagine entire seas rising into walls of water, collapsing back with unimaginable force. No shoreline was safe. For life near the impact zone, survival was impossible. The tsunamis were only one terror among many, but they remind us how violently Earth can respond when the cosmos collides with our world. Fire, rain of fire. The force of the impact blasted molten rock and debris high into the atmosphere. Red-hot fragments spread around the globe and rained back down, igniting wildfires on every continent. Some scientists believe the planet's surface may have glowed with heat as embers fell from the sky. Forests burned, plains burned. Entire ecosystems were consumed in a global firestorm. For dinosaurs, it was not just the impact that killed them, it was the aftermath. A world engulfed in flame, smoke, and chaos. New moon, the long night. Perhaps the most devastating effect came not from fire or water, but from darkness. Ash, soot, and dust filled the atmosphere, blocking sunlight for months or even years. Earth entered an impact winter. Photosynthesis collapsed. Plants withered. Temperatures dropped. Ecosystems that had thrived for millions of years suddenly faced cold, hunger, and perpetual twilight. Imagine a world where the sun does not rise, where forests fade into silence, and where the rhythm of life stops. The dinosaurs had evolved for warm, bright worlds. Darkness was their undoing. Seedling collapse of life. Without sunlight, plants died. Forests turned into skeletons. Herbivores starved. Predators soon followed. The web of life unraveled from its foundation upward. Fossil records show a sudden collapse in biodiversity. Once vibrant ecosystems fell silent. Imagine walking through a Cretaceous forest alive with movement, then returning a year later to find it barren and still. The asteroid did not just kill with impact and fire. It killed with famine. It erased food itself. Globe showing Europe, Africa, a mass extinction. More than 75% of all species on Earth went extinct. Dinosaurs were the most famous casualties, but marine reptiles, flying pterosaurs, plants, and countless invertebrates vanished as well. Entire branches of life were erased in a geological instant. Only a fraction of life endured, small creatures, burrowers, survivors of darkness and scarcity. This mass extinction reset the planet's balance, clearing the way for mammals and, eventually, humans. It is humbling to realize how close life came to being transformed beyond recognition. The asteroid did not just end an era. It rewrote Earth's future. Bird dinosaurs never truly left. Not all dinosaurs vanished. A small feathered lineage of theropods survived, the ancestors of modern birds. Their small size, flexible diets, and ability to fly helped them endure the catastrophe. From those survivors came every sparrow, pigeon, hawk, owl, and penguin alive today. In this sense, dinosaurs never truly disappeared. They still soar in our skies, perch on our rooftops, and sing in our trees. Every bird is a living dinosaur, carrying ancient DNA, ancient anatomy, and ancient history into the present. When you hear birdsong, you are hearing the echo of the Mesozoic. The extinction was never truly an ending. It was a quiet transformation, a turning of the cosmic page. When you hear birdsong in the early morning, you are listening to echoes from the age of dinosaurs. Those soft melodies are the final voices of a world that once thundered with colossal footsteps and roars that shook ancient forests. Every sparrow perched on a branch, every eagle gliding across mountain winds, every penguin sliding across Antarctic ice is a living dinosaur, carrying the ancient lineage of theropods in their bones, feathers, and instincts. It's easy to forget how extraordinary this is. From the smallest hummingbird hovering like a jewel in the air, to swans drifting across silent lakes, birds are survivors of a planetary catastrophe. The dinosaurs did not simply disappear. They adapted. They changed. They shrank and transformed, carrying the Mesozoic era forward into the present moment. The next time you see a bird take flight, remember that you are watching a story that began more than 200 million years ago. A story written in scales and feathers, in extinction and survival, in silence and song. Dinosaurs still walk among us, hidden in plain sight, whispering the memory of an age when giants ruled the earth. And so, dear listener, our long journey through deep time slowly comes to a gentle close. Together, we wandered across ancient landscapes, from quiet riverbeds where fossils waited patiently to be found, to fiery skies lit by an asteroid that changed the destiny of life itself. We walked beside towering giants with necks like bridges between earth and sky. We traced delicate feather patterns preserved forever in amber. We watched prehistoric forests bloom with flowers while immense herds moved like living mountains across the land. Even their footprints, pressed into soft mud millions of years ago, still whisper stories across time. Dinosaurs remind us that life is endlessly vast and wonderfully strange. They teach us about resilience and fragility, about beauty and terror, about silence and sound. They ruled the planet for more than 160 million years, far longer than humanity has existed so far. And still, their legacy beats quietly in the wings of every bird that rises into the sky today. The sparrows in your garden, the penguins in distant frozen oceans, the eagles soaring over mountain ridges. Each one is a living reminder that the story of dinosaurs is not finished. It is still unfolding, softly and silently, in the rhythm of wings and the breath of the world. As you lie here, letting your breathing slow, imagine the earth as it once was. Picture a lush Jurassic forest, warm and green, filled with ancient life that feels strangely familiar. Hear the distant rumble of footsteps, steady and deep like the heartbeat of the planet itself. See the shimmering colors on feathered raptors, the towering silhouettes of sauropods moving like walking mountains, and the delicate glitter of giant dragonflies dancing through the air. Watch it all slowly fade into stillness, into memory, into dreams. The dinosaurs lived. They thrived. They shaped the world. And then they transformed, leaving space for something new to emerge. In that way, they remind us that endings are never truly endings. They are transitions, gentle shifts, quiet turning pages in the endless story of the universe. Just as their world gave way to ours, the day gives way to night, and waking thoughts drift into dreams. If you are still awake, you can continue your journey with the next story whenever you feel ready. But if your eyes are growing heavy, let these ancient echoes carry you softly into rest. Close your eyes, breathe slowly and deeply. Let yourself drift into sleep, into stillness, into the vast and timeless silence where even giants once dreamed. Good night.